Hello and welcome to FAD Learning. Angular version 19 was officially released on November 19, 2024. And in this video, we will dive into the latest features covering both theoretical concepts and practical examples. So this comprehensive video will provide you with everything you need to know about Angular 19. Therefore, to start, we will spend the first 5 to 6 minutes reviewing the key updates. Then we will dive deeper into each new feature, providing a detailed understanding of what's new and how to use it. So let's start with the first update. The default setting for standalone is now true. Angular 14 introduced standalone components, streamlining dependency management. However, developers needed to explicitly enable this feature by setting standalone true in their code, since it was not enabled by default. And starting with Angular version 19, all components, directives, and pipes are now stable by default. This means you will never need to write standalone true again. And what about your existing Angular code? When you update to version 19, the ng update command automatically refactors your code, ensuring everything works seamlessly. This includes components, directives, and pipes in modules will include standalone false, and unnecessary code from existing standalone components will be removed. Next, we'll talk on updates on Signal. What's new and updated? In Angular version 19, the Signal and computed APIs have reached stability. Building on this, the Angular team has introduced more signal-based API and stabilized single-based query APIs, including input and output. These two are the signal-based input and output properties for components. Next, module for signal-based two-way data binding. Next, viewChild, signal-based query for child component. Then viewChildren for multiple child components. Content child for content child component. And last, content children, signal-based query for multiple content child component. Additionally, Angular version 19 introduces several new and experimental APIs. First, let's talk on Signal API, called as linkedSignal. LinkedSignal works similarly to Signal, but with one key difference. It's connected to a computed expression that sets its initial value, and we can update linkedSignal freely, just like a regular signal. But when the computed expression changes, linkedSignal automatically reverts to its calculated value. And to learn more about linkedSignal, including examples and use cases, kindly check out my video. The link is available in the description below. Next, let's talk on new and experimental resource API. Angular 19 introduces two experimental APIs, resource and rxResource, to simplify asynchronous data retrieval. And this API provides the unified approach for retrieving data using both promises and observables. Resource API provides a promise-based interface for data retrieval, whereas rxResource API offers an observables-based interface for data retrieval. And these APIs aim to streamline data management, reducing complexity and improving efficiency. Now, next feature is stabilization of inputs, outputs, and view queries. Under this, let's discuss the new automatic refactoring tools introduced in Angular version 19. There are three separate tools, and we can choose to run them on our code. So the first tool is Signal Input Migration. It converts inputs using the decorator API to the new signal based inputs with command ng generate @angular /core signal input migration. Next tool is output migration. It updates components to the new function based output API and run this with command ng generate @angular /core output migration. And the last tool is signal queries migration. It replaces queries like viewChild and content child with signal based equivalents. And to run this migration, use command ng generate @angular /core signal queries migration. Now let's proceed to discuss the updates on hydration. Angular 16 supports full application hydration, enabling Angular to hydrate the entire application at once. And then Angular 17 introduced deferrable views or defer block, allowing developers to delay hydration of specific views or components. After that, Angular 18 introduced event replay, enabling replying of events on hydrated components. And Angular 19 now includes incremental hydration. It allows Angular to hydrate components independently as they become visible on the screen rather than hydrating the entire application at once. And this approach improves page load times, reduces initial hydration overhead, and enhances user experience. Now let's talk on Angular material updates. Angular material continues to shape the Angular developers landscape. So let's explore the latest improvement in Angular version 19 updates. So the Angular team has introduced enhanced theming API for simplifies customizing and managing application themes. Next, component overrides allows developers to customize and extend Angular material components. Next is two-dimensional drag and drop for enhanced UI interaction with two-dimensional drag and drop functionality. Next, support for tab reordering to improve user experience capability. And last, a brand new time picker component for streamlines time selection with a dedicated time picker component. It supports 12 hours as well as 14 hours formats. And last, let's discuss on TypeScript version. Angular 18 previously supported TypeScript version 5.4, but Angular 19 now supports TypeScript 5.6. This means that we can use the latest version of TypeScript in our Angular applications as TypeScript 5.4 is no longer supported. So far we have covered the updates in Angular 19, and now let's dive deep into the newly added features with practical examples in an Angular 19 project. So first, let's dive into upgrading our Angular application from version 18 to the newest version 19. So let's start by setting up our Angular 19 environment. This includes using TypeScript 5.6, which we discussed in our previous video on Angular 19 updates. Therefore, to begin, we will need to install Angular 19 and TypeScript 5.6 on our system. In my case, let's check the current version of TypeScript using the command tsc space -v. And as you can see, I already have version 5.6 installed, and which is the latest and required version for Angular 19. Older versions of TypeScript are not compatible with Angular 19. Therefore, kindly install the latest TypeScript version to work with Angular 19. And to install the latest version of TypeScript, use command npm install -g TypeScript @latest. So with this npm command, we can install the latest version of TypeScript. Next, Angular 19 supports Node.js version greater than 18.19.1, consistent with Angular 18. Therefore, no Node.js version update is required for this migration. So now let's check the Angular version using command ng space v, and you can see my Node.js version is up to date, but I still need to install Angular 19 on my system. So I need to update the Angular CLI, and to do this, run command npm install -g @angular/CLI and hit enter. This command updates the global Angular CLI to the latest version. Okay, I added 33 packages. And one more thing, if you want to install a specific version of Angular, then simply append the desired version number after @angular/CLI using symbol. For example, if I want to install the Angular version 17, then we just need to provide the version number. That's it. Now let's check the Angular version again using same command ngv. And as we can see now, Angular 19 has been successfully installed. Okay, so just to recap, before starting the Angular migration, let's review what we have done. First, install the latest TypeScript version, that is 5.6. Second, verified that no Node.js version update is required for this migration. And third, installed Angular 19. So now we have successfully prepared our environment for migrating the Angular application from version 16 to 19. Now I have an Angular 18 project that I'll open in Visual Studio Code using command code space dot. And here inside the package.json file, you can see that this project is currently on Angular version 18. So I'll run this project first, then upgrade it to Angular 19. Okay, so I'll run this project using ngs, hit enter, and I'll open the browser on localhost 4200. And here we can see a user table with a list of users. Now I'll go back to Visual Studio Code, and here to update the Angular application, I'll open separate command prompt in the same path, cmd, and here I'll run command ng update @angular /core @19 space @angular /cli @19 and hit enter. I'll just minimize this, and here after a few seconds you can see the package.json file. The Angular version will get update with 19. Also we can run ng update command to check the migration status. There you can see which dependencies are pending, and it will also provide commands to upgrade them. Okay, so this process will take few seconds, depends on your internet speed, and to complete the migration successfully, we need to follow several instructions. Here you can see updating package.json file. Also you can see the version of Angular CLI is now 19, and Angular /compiler CLI is also 19. So let's wait for a few more seconds. So here to proceed with this dependency, simply press space and then enter. Same for this dependency, space and enter. And finally, you can see the message migration completed. And package.json file now reflects the updated Angular 19 version. Additionally, if you click on this source control, you can view the list of updated files here. And as discussed in our Angular 19 new features video, standalone components are now the norm. Starting with Angular 19, all components, directives, and pipes are standalone by default. So here, inside app.component.ts file, notice that the standalone true option has been removed. Okay. Now let me rerun this project again. ELS. I'll run this project with ngs to see if it's working as it was previously. Okay, I'll open the browser, reload this page, and as you can see, our project is running as expected. Okay, so this concludes the successful migration of Angular 18 application to Angular 19. And stay up to date with the latest developments by visiting angular.dev, navigating to Angular 19, and search for the update guide. You will find the comprehensive upgrading information. Now let's move on to standalone components. Standalone components streamline building Angular applications while enhancing performance. Since they don't require an ng module, we can build and use components without declaring them in an ng module. So this video covers the standalone components feature introduced in Angular 19, which is enabled by default. We will dive into the basics of standalone components and demonstrate how to integrate them into other components. So first, let's talk on evolution of standalone component. In Angular, components are the fundamental building blocks. Normally, when we create a new component, it must be declared in the module where it's being used. But with Angular 14 and later, we can create standalone components that can be used independently without being part of any ng module. So, Angular 14 introduced standalone components in developer preview. By Angular 15, they became stable. And from Angular 15 to 16, we could create standalone components using the ng generate component name --standalone command. Starting with Angular 17, the ng generate component name command creates standalone components by default by adding component property standalone true. And with Angular 19, all components are standalone by default, eliminating the need to add component property standalone true to your code. And when you update the existing code to Angular 19, the ng update command automatically updates your code. You don't need to take any explicit action. That we have already seen while migrating Angular application from version 18 to 19. Now let's go inside Visual Studio Code and create a new component in the Angular 19 application. Inside Visual Studio Code, I have created an Angular 19 application. So inside package.json, you can see that this project is running on version 19. Okay. Now let me open terminal, and here I'll create new component inside this project. And from Angular 19 onwards, components are standalone by default. So here to create the component, I'll use command ng generate component name test. Enter. And here you can see the test component has been created successfully. Now, inside this test component.ts file, you can see that there is no standalone true property under the @component decorator. This is because from Angular 19 onwards, standalone true is the default. Also, you can see the same thing inside app.component.ts file. Under this @component decorator, there is no standalone true property available. Now, if I want to reuse this test component in app component, I need to add the selector of test component to the app component. And the selector is defined in the test component.ts file, that is app-test. So let me add this selector to the app component file. Here, before this router outlet, I'll add app test. Okay. So I have added the test component selector inside app component.html file. Now save the changes and let me add some new text in both components. This is test component. Save the changes and inside app component.html, here I'll add one h1 tag, and inside this I'll write the text. This is app component. And as of now, I'll just comment out this router outlet and save the changes. And now let's try to run this project with command ngserve or ngs. Hit enter. So here you can see we are getting an error on line number 2, that is on test component selector. If you want to render the test component inside app component, then first we need to import that component inside app.component.ts file. So here inside imports array, I need to import test component with an import statement. This test component import from test/test.component. And now you can see error has gone, but Angular 19 now prompts an error to remove unused imports. So we are not using router outlet. So as of now, I'll delete this and now save the changes. And now you can see there is no error. So let me open browser on localhost 4200. And here you can see the content of both user component as well as app component. This is app component and this is test component. And now if I want to use *ng if directive inside this app component, so here let me declare one variable is login of type boolean equals to true. And I want to use this is login variable inside h1 tag. I'll use *ng if directive and I'll pass this is login variable inside this ng if. Now save the changes and you can see we are getting an error. Can't bind to ng if since it is not a known property of h1. And to fix this error, we need to import common module inside this imports array. Now save the changes. You can see error has gone. And you can see the output of both components. So it means if you want to use any dependencies for this app component, then first we have to import it inside this imports array and then we can use it for that component. Okay, so without standalone component, we had to declare all components inside this declaration section and require dependencies inside this imports array or imports section within a @Angular module like this. And this made it difficult to identify which components relied on each other. But now With standalone component, we can clearly see the dependencies for each component. And the standalone component optimize Angular application development by reducing the need for ng modules. And this approach helps to eliminate unnecessary imports and unused dependencies, which can increase bundle sizes. Now let's move on to the next feature, incremental hydration. Performance is key to any successful application as it directly impacts user experience and engagement. So in this video, we will dive into incremental hydration introduced in Angular 19 for optimizing application performance. So we will learn what incremental hydration is, how to implement it in our Angular 19 application, what are the benefits of incremental hydration, and much more. But before we start, I would like to invite you to subscribe FED Learning as we are covering all new features of Angular 19 in our upcoming videos. So by subscribing, you will never miss an update from FED Learning. So first, what is the use of incremental hydration? Incremental hydration is a feature that allows developer to lazy load specific parts of their application, which improves performance by reducing the initial payload size and enhancing user experience. So before diving deep into incremental hydration, let's understand first what is hydration and how to enable it. Hydration is a technique used in server-side rendered application to enhance performance. And how to enable hydration? Hydration requires server-side rendered application, and to enable hydration, we can either create an SSR application, means server-side rendered application using Angular CLI, or we can add SSR to an existing application via command. Like here, I have created an Angular 19 application called Incremental Hydration with server-side rendering enabled. And to do this, simply select S when prompted during application creation. And if you missed this step, you can easily add SSR later by running this command ngadd@angular/SSR. And once this is done, the necessary hydration code is automatically included in the application. Okay, so this is a brief introduction to hydration. Now let's understand what is incremental hydration. Incremental hydration is an advanced hydration technique that enables Angular to dehydrate or remove non-essential parts of the application and rehydrate or load those parts incrementally as users interact with them. Okay, so this is the definition of incremental hydration. Now let's see how do we enable it in Angular. We can enable incremental hydration by adding with incremental hydration function to the provide client hydration provider. And we need to note one point here. Incremental hydration relies on event replay and enables it automatically. So if you have already set up event replay in your configuration, you can remove it after enabling incremental hydration. Like, let me open Visual Studio Code. And let me go inside configuration file app.config.ts inside providers array. So as shown here, we can replace with event replay function with incremental hydration, and which is imported from Angular/platform browser package. Okay, so by adding with incremental hydration function, we can enable the incremental hydration in Angular 19 application. Okay, save the changes. And next, let's understand how to implement incremental hydration in our Angular application. The deferrable views or defer blocks are the building blocks of incremental hydration in Angular, and they define when to hydrate content using conditions like hydrate on, hydrate when, and hydrate never. So there are three types of hydrate triggers. Hydrate on, it trigger hydration based on specific events. Next, hydrate when, it hydrate content when a condition is met. And third, hydrate never, it prevent hydration entirely. So in order to use these three hydrate triggers, we need to add them to each @defer block. And also we can specify multiple hydrate event triggers separated by semicolon. Now let's understand these three types of hydrate triggers with practical examples. So I will switch back to Visual Studio Code and we will continue from there. So here I'll create the new component with command ng generate component, and component name is user. Hit enter. Okay, so you can see here user component is created. Now in order to render this user component on browser, I need to add the selector of that user component inside app.component.html. So here I'll add app user, and also I need to import the same component inside imports array. It is user component. Now save the changes and run this project with NGS. Now let me open browser on localhost 4200, and here you can see our user component is rendered on browser. Okay, now inside user component I will add one user table with dummy data. Okay, so here I have added user table with this dummy data. Now let me remove this router outlet from this app.component.ts file. Now save the changes and go back to browser. And here you can see the user table with list of users. Now we will implement the code for 3 types of hydrate triggers on top of this user table. Okay, so let me just close this user component and I'll open the app component HTML as well as DS file. Okay, so here first let's understand about hydrate on trigger. And hydrate on trigger triggers hydration based on specific condition. And under hydrate on, there are 6 triggers such as interaction, hover, timer, viewport, idle, and immediate. And to use any of these hydrate triggers, we need to add them to each @defer block. So here I will write one defer block and I will shift this app user selector inside defer block. Okay. And also I will add one placeholder here with message user table loading. Now inside this defer block, I will add the hydrate on triggers. And how to add hydrate on triggers? We just need to type hydrate and then on and then the trigger name. So under hydrate on trigger, there are 6 triggers: interaction, hover, timer, viewport, idle, and immediate. So first I'll start with interaction trigger. So we just need to write hydrate on interaction inside this round bracket. And this hydrate on interaction trigger render or hydrate the component when the user interacts with the specified element. In our case, the component is app user, and inside this user component, we have added one user table with list of users. So once you interact with that table, this user component will rendered on server side. Okay, now save the changes and go back to browser. Here I'll open developer tool. And how to test the incremental hydration? The content is rendered on the web, but not on the server side. So to understand this clearly, I'll log one message inside ng onInit lifecycle hook. So inside user.component.ts file, here I'll implement this user component with onInit lifecycle hook. And here I need to implement ng onInit, and inside this method, I'll log one message user component rendered on server. Okay, now save the changes and go back to the browser. Here you can see on initial load, the message does not appear on console. But when I click anywhere in the table, the user component rendered message will log to the console. Now I am clicking on this table and you can see as expected, after clicking on table, the message user component rendered on server has been successfully logged to the console. I'll do this one more time. Refresh the page, click on the table, and message is logged to the console. Additionally, we can see the server-side rendered component on a source code. So here we need to go inside SRC, and here is our user component. Okay. Let me refresh the page And you can see inside user component, there is only one .css file has rendered. And now I click on the table. You can see the remaining two files also rendered on server. Okay. So now let's try with another trigger, which is called as hover. Hover. Okay, here. So let's test this in the browser. As you can see, only one file under user component. But once I over to this user table, the complete user component will be rendered. Let me refresh the page one more time and I'll expand this user component. And now I'll hover over to this user component and you can see the remaining two files also rendered under user component. Okay, now let's move on to the next trigger, that is viewport. And this viewport trigger activates when a specified content enters the viewport. So to understand this, I will add some space before user table inside .html file. Let me add br tags here. Okay, now save the changes and go back to browser. Here you can see once I scroll down and the user table enters the viewport, the user component will get rendered on the server. Here you can see. Once I scroll down, you can see the complete user component is rendered. Now one more time, I'll refresh this page and I'll expand this user component and now I'll scroll down and once this table enter into the viewport, the respected component is rendered on server. Okay, now let's try the next trigger. I'll comment out this br and inside app.component.html instead of viewport here I'll use another trigger, that is timer. This timer initiates hydration after a specified duration. So here we need to set the duration, set 2000 millisecond, and as a result the user component will render after specified time, means after 2 seconds. So let's test this. I'll refresh the browser and under user table you can see. Okay, let me increase the time. I'll pass 500 millisecond. Refresh the page and then 1, 2, 3, 4, 5. Now you can see all files under user component. Same we can see on the console. Let me refresh the page again and you can see after 5 seconds the message will appear on console. Here, user component rendered on server. So this is all about timer. And one more thing, hydrate triggers are additional triggers that we can use along with regular triggers, separated by semicolon. So here I can use regular trigger, that is on immediate and then semicolon and then I can use this hydrate on trigger. Okay. Now next idle trigger. So here instead of timer I'll add idle. And this idle trigger activates when the browser is idle. And we can use it similarly to hover or interaction triggers. Okay. Lastly, we have the immediate trigger. And this immediate trigger triggers hydration immediately after the non-deferred content has finished rendering completely. Okay. Now save the changes. Here you can see the user component rendered on server message are rendered immediately on console. Okay, now let's review what we have covered so far. So to recap, we have explored the 6 available triggers under hydrate on. First is hydrate on idle. It triggers when the browser is idle. Second is hydrate on viewport. It triggers when specified content enters the viewport. Third is hydrate on interaction. This trigger triggers when the user interacts with specified elements. Next, we have seen hydrate on timer. It triggers after a specified duration. Next, we have seen hydrate on immediate trigger. This triggers immediately after non-deferred content has finished rendering. And last, we have seen hydrate on hover. This trigger triggers when the mouse hover over to the specified area. Now let's understand the next hydrate trigger, that is hydrate when. First, we'll see the example and then we will come back to this presentation. So here, instead of hydrate on, I'll write hydrate when. And this hydrate when trigger allows you to specify a custom conditional expression. Like after this when, we have to provide the condition. And when the expression or condition evaluates to true, Angular loads dependency and hydrate the deferred content. So to demonstrate this, I'll define one Boolean variable called isLogin of type Boolean equals to true. Okay. And I have used this isLoggedIn variable as a condition for this hydrate when trigger. Now save the changes and go back to browser. I'll go inside source. And here you can see the user table is rendered only when isLogin is true. And in other hand, if I change to false, and here instead of immediate, I'll change this to hover or interaction, anything. Go back to browser and here you can see the user component will not get rendered. So it means the user component is rendered when the condition isLogin is true, and in other hand, when isLogin is false, the user table will not get rendered. Okay. So hydrate when trigger accepts a custom conditional expression. When a condition becomes true, the Angular loads the deferrable views dependency and hydrate the content. And this is the syntax of hydrate when trigger. Hydrate when and then we need to specify the condition. Next is hydrate never. Hydrate never keeps content in defer block hydrated indefinitely, making it static or initial render. However, dependencies are fetched on subsequent client-side renders. Meaning, hydrate never tells Angular to never render the content within @defer block, and this means that content will remain static and will not be rendered or updated by Angular. And the syntax of hydrate never is hydrate space never. That's it. Let's try this. Instead of when condition, I'll write never. Now save the changes and go back to browser. Here you can see Angular won't render the user component at all. I'll open the console and here also you can see we are not getting the message user component rendered on server. Okay, so by using hydrate never, we can optimize our Angular application performance by skipping unnecessary rendering and updates. Okay, now let's understand how does incremental hydration work with nested @defer block. So for that, here I'll first write an example of a nested defer block and then I'll explain. Okay, so here you can see I have written an example of nested defer block. This defer block is for parent component and this defer block is for child component. So in this example, when you hover over to the nested defer block, that is this child component, the hydration process begins. And the parent defer block hydrates first, followed by the child defer block. Okay, so nested hydration means each component has a parent-child relationship with other component, and hydrating a child component requires its parent component to be hydrated first. And this ensures that the parent component's dependencies are resolved and their content is rendered before the child component is hydrated. Okay, so that's all about practical implementation. Now let me go back to the presentation and let's discuss on when to use incremental hydration. First is large-scale applications with complex features. It means we can use incremental hydration to break down complex applications into manageable chunks. Second is applications with multiple rarely used features. Means we can use incremental hydration to load rarely used features on demand and reducing initial load time. And third, performance critical applications. Use incremental hydration to optimize loading for seamless user experiences. And last, what are the benefits of incremental hydration? First benefit is reduced initial payload size results in smaller bundle sizes leading to faster page loads. And second benefit is improved performance is achieved with only loading necessary codes, which reduces computational overheads. And third benefit is enhanced user experience, and it is provided through faster interaction with critical application features. Okay, so to conclude, incremental hydration in Angular 19 offers a powerful tool for optimizing application performance, and by loading application features selectively, developers can build faster, more efficient, and more user friendly applications. Now, let's move on to the next feature, the new experimental resource and signal API. We will start by covering the resource API, followed by signal API. Angular 19 introduces a new way to handle HTTP requests using the resource API. So in this video, we will explore the new features, resource and Rx resource with a simple example. And we will utilize these two resource API in our project to perform asynchronous operations. So here inside Visual Studio Code, I have created a user table and utilized HTTP client to make HTTP requests to the server. And these requests retrieves data from this JSON placeholder users API. And here is the output, a user table populated with a list of users. If I hit this API on browser, you can see the 10 users available in this API. And we are displaying the same 10 users on our browser. Okay, so now instead of this HTTP call, I am going to use the resource API to retrieve the same data. So here I'll comment out this get data method, and below this get data method, first we will explore an example using rxResource API and followed by an example using resource API. And these resource and rxResource API serves the same purpose. The only difference is that rxResource works with observables, whereas resource works with promises. So now let's define a variable with name rxResource data equals to, here I'll call a rxResource API, which is imported from Angular/core/RxJS interop package. And now I need to pass an object with a loader function. Loader, and here I'll use an arrow function to call the HTTP GET request. So here I have already injected HTTP client through constructor. So here I'll use HTTP.get of type any, and inside bracket I'll pass this.url. So here rxResource automatically subscribes to and unsubscribes from the observable, and it considers only the first emitted value similar to the RxJS first operator. So this behavior is particularly suitable for HTTP operations, which typically emits a single response and then complete. Okay, I'll save the changes and go back to browser. Let me access the data stored in the rxResource data variable, and we can access the data from resource and rxResource API using the dot value, variable name dot value, and then round bracket. Now save the changes and go back to browser, and now you can see that we are able to access the same data using the rxResource API. Okay, so this is the basic understanding of rxResource API. And now let's dive into resource API. Let me comment out this rxResource API code and perform same async operation using resource API. So here I'll create new variable with name resource data equals to, this time I'll use resource API instead of rxResource, and which will import from Angular/core. Okay, and this resource API is similar to rxResource API. So here I'll pass an object with loader function. Here I'll use arrow function, and after that, instead of this HTTP GET, I'll use fetch method. Here I'll pass this dot URL. After that, dot then, inside round bracket, response arrow function, response dot JSON as promise of type any. Okay, so in this resource function, this fetch method send the HTTP request to this URL, And after that, then response equals to response.json means after receiving a response from this URL, this code passes the response data as JSON. And last, as promise of type any, this is a type assertion indicating that past JSON data is a promise of type any. Okay, hope you understand this line. I repeat, this loader function fetches data from the URL, passes it as a JSON, and returns the result as a promise. That's it. Now, inside HTML, I'll replace RxResource data with resource data. Now save the changes and refresh the browser. And here you can see once again we have successfully accessed the same data, but this time using the resource API. So to conclude, use resource API for asynchronous operations that return promises, and use rxResource API for asynchronous operations that return observables. Now let's understand the last feature, the Signal API. Under the Signal API, the Angular team has released a linked signal function. So first, let's talk on evolution of signals. Signals were first introduced in Angular 16 in developer preview, but support for many features was limited. For example, signals could not be used as inputs to components. Next, signals become stable in Angular 17, and Angular 18 further improved signal stability. Additionally, it introduced zoneless change detection with signals, offering a more effective and lightweight approach to detecting changes. And Angular 19 introduced a new concept in developer preview called linked signal. So now let's understand the implementation variants of linked signal. Linked signal supports two implementation variants. First, linked signal with shorthand syntax, and second, linked signal with source and computation. So let's start with simple example to understand this syntax, and then we will move forward. I am inside Angular 19 project. Here I am going to create a new component with name link, ng generate component name link. And I assume you are familiar with Angular 18 signals. There are two types, writable signals and computed signals. And apart from computed signal, now Angular has introduced a new feature called linked signal for defining signals that depends on other signal. So here you can see link component has been successfully created. Now I'll add the selector of this link component to the app component.html file, app link, and additionally I need to import the link component inside imports array of app.component.ts file. Now let me run this project with command ngs. Now let me open browser on localhost 4200, and here we can see the link component changes in the browser. Now let's start the actual coding. Let me open link signal HTML file and .ts file, and let me close the remaining files. Now inside this links component.ts file, here I'll create a writable signal named current email with an initial value of an object containing ID and name properties equals to signal, which is imported from Angular/core package. And next I'll create a computed signal named alternate email, and this signal returns a string representing an email address. Computed arrow function, and here I'll use string literals dollar inside curly bracket this dot current email dot name @gmail.com. And now inside HTML file I want to display the value of alternate email signal when the button is clicked. And to achieve this, here I'll create one button with label alternate email address, and I'll add a click event that calls a alternate email ID function. After that, inside paragraph tag, I'll display the text email address. followed by the value of alternate email signal using a string interpolation and invoking the signal as a function. And here I want to use a line attribute center. And I need to define this alternate email ID function inside TS file. And in this function, I'll set different values to current email signal using the dot set method. Current email dot set and then object ID equals to 2, comma, name equals to FAD learning. Now I'll save the changes and let's observe the update in the browser. Now here you can see on page load. Let me add the B tag to this alternate image. Now you can see on page load the email address is fad@gmail.com, and when I click on this alternate email address button, you can see that the email address changes to fadlearning@gmail.com. So our code is working as expected with writable and computed signal. Okay, let me correct the spelling of alternate ALTER and let me go back to .ts file. And now, since computed signals are read only, we cannot directly set the value to it, unlike writable signal. And to overcome this restriction, we can use linked signal, which is available in two forms: linked signal with shorthand syntax and linked signal with source and computation. So first, let's understand linked signal with shorthand syntax. And for that, we simply need to replace the computed with linked signal, which is imported from Angular/core. That's it. Now it's officially a linked signal, not a computed signal. Let's verify in the browser to ensure the functionality is still working as expected. I'll click on this alternate email address button and you can see that email address is changing to fadlearning@gmail.com. Now let's explore the next syntax of linked signal with source and computation. I'll just comment out this line and let me refactor this linked signal with source and computation configuration. So now the link signal function requires an object with two properties, source and computation, and to pass the expected values, instead of this, I'll create an object inside the link signal with property source and computation. Now this source property identifies the dependency signal. So in this case, linked signal depends on writable signal, that is current email. And the computation property defines the computation function that will be executed when this source value or the current email value changes. So here I'll use the same logic as before. Okay. So how does it work now? When the current email value changes, the linked signal detects the update and the computation function is then executed and displaying the email address with new current email value. And the results become the new value of alternate email. Now let's check the output in the browser. Let me click on this alternate email address button and you can see the alternate email address on the browser, that is fadlearning@gmail.com. Okay. Now linked signal uses one more property called equal, and this property is used to specify a custom equality function for comparing values. Equal colon. So here we need to provide the a and b value, a of type any, comma, b of type any. And it is similar to a sort function in JavaScript, arrow function. Then we need to match a.id triple equals to b.id to determine whether the two values are equal. So in this case, we can check whether the ID properties of two objects A and B are equal. And here you can see that our first object ID is 1 and second object ID is 2. It means our IDs are different. And if the ID properties are not equal, this function returns false, indicating that the values are not equal. And if this equal function returns false, the alternate email value will not get updated in the browser. Now save the changes and go to the browser. And here you can see that on click of this button, the alternate email address is not updating. And if I change the condition to not equal to, now in this case, this equal function returns true. And if this function returns true, the alternate email value will get updated in the browser. Now let's check in the browser. Click on this alternate email address button And this time we can see the updated email address in the browser, that is fedlearning@gmail.com. So this equal property allows us to provide a custom function that takes two values as arguments and returns a boolean indicating whether they are equal or not. Okay, so this is the example of linked signal with source and computation configuration, and this is the example of linked signal with shorthand syntax. Now I'll go back to PPT and let me read the definition of shorthand syntax. This provides a simplified syntax for creating linked signals, making your code more concise and easier to maintain. And the definition of linked signal with source and computation is: this allows us to define a source signal and a computation function to determine the updated value of linked signal. Now last, let's talk on other signals versus linked signal. And this signal and computed signal come under the category of other signals. So signal is a function from @Angular/core module that creates a signal. And it is a value that can change and notify others, similar to observables. And what is computed signal? This is also a function that creates a computed signal, and computed signals are read-only signals that automatically update based on other changing values. And what is meant by linked signal? A linked signal is a writable signal that updates when the value of associated signal changes. Okay, so that's all for linked signal. And kindly note that this linked signal API is still in developer preview, but it might change before it is stable. That concludes our Angular 19 updates. I hope you found this video informative and engaging. If yes, please do like, share, and subscribe to FED Learning for quick and easy learning. Thank you for your time. Bye bye.